Here they
We
come.
are live. Day 7, is it? Day 7?
Day 7, yeah, sorry, day 7.
Day 7, very exciting day 7. We've got a special guest who will introduce shortly. But those of you that are regulars for tech recruitment training will know we will sit here awkwardly for a couple of minutes and make some small talk whilst we wait for everybody to join. So whilst we do that, let's make the normal small talk. Phil, why don't you tell us, highlight and lowlight so far of TRT?
Well, I don't think there've been any lowlights. I don't think we need to go down that route. No, I think it's been all positive so far. I think highlight was probably Friday's session. I think, like you, really enjoyed getting into the pretty complex stuff, talking about microservices, talking about the modern stuff. That's typically what we're looking at on a weekly basis when we're speaking to companies that are looking to hire modern software engineers. So yeah, I think the modern software engineering stuff on Friday was definitely my highlight.
Nice. I think something that I don't think we planned necessarily, but seems to have worked really nicely is kind of like the timelines, because last week all kind of built up to, that modern software engineering, non-functional requirements, and then that leads really nicely into DevOps and the topics covering this week as well. Yeah,
I mean, in today's session, we're going to look at some non-functional requirement stuff. We look at how cloud computing's impacted DevOps, but there's also a lot of correlation between how cloud computing's impacted microservices, a lot of the other sort of topics that we discussed on Friday. So yeah, it just joins more dots for people, I think.
Nice. And for those that are joining, don't worry, you haven't missed anything yet. We're just waiting for others to join. We'll wait another couple of minutes or so. What about you, Daz? What's been your personal highlight?
Personal highlights, writing the content for Thursday, because it's going to be an absolute banger of a session. Personal low light, probably missing Friday's session. It's the first one that I've not been involved in, so that's a low light for me. I love these sessions so much.
Yeah, to be fair, I think the Darren Eddercott fan club did miss you on Friday. We definitely received a few messages to say, "Where's Darren?" I think Phil probably got a little bit more.
Oh, what? Sorry?
You got a bit more love on Friday because I wasn't there.
Yeah, absolutely. Yeah, not there stealing my thunder. No, to be honest, I wasn't not being involved in yesterday's. It was annoying because it would have been great to get on and have a chat, but I had so much admin built up that actually was a little bit of a blessing in disguise. But yeah, looking forward to getting on with today. Obviously, being on tomorrow and on Thursday as well. Get back in the rhythm of it.
You two, you've been a viewer in all these sessions so far. What's been your personal highlight and low light?
I don't think there's been any low lights, the highlights. I think I really enjoyed yesterday's session about DevOps because I work in DevOps, obviously, and I thought it was quite a good, thorough explanation of just what DevOps is, because it can be quite hard to understand, especially if you just started working sort of with DevOps candidates. Just what it is, is that a tool, is it because it's quite different from anything else, just your usual sort of software engineers.
Nice. Guys, because I'm sharing my screen, I can't see the time and stuff, so just give me a nod when you think we should go, but for the time being we'll keep making a bit more small talk whilst everyone joins, and for those that have joined, feel free to jump in the chat and tell us your personal highlights of the 7 sessions so far. What's been the best session? Let's get the chat going today. Hey Daz, I know you're going to be on the chat. I know you like jumping in there and starting some interesting conversations. Cool.
So far, the first message that goes in there is DevOps, and obviously being the person that led that one, I agree.
always a humble man. Hey Darren.
Exactly. If we, I think if we start in about 30 seconds time.
Brilliant.
Got to about where we expect to be.
Cool. I feel like a TV presenter now, where they're counting down in your ear 30 seconds. Nice.
A man that everyone at Hackajob will know, Mr. David Franklin, has said that yesterday's session was great, and of Fridays as well.
Nice. Hey David, hope you're well. Long time no see. Long time no speak. Looking forward to some cocktails once all this is over.
I think I'm looking forward to so many cocktails when this is over.
The Negronis, if I remember correctly.
Negronis, yeah, Negronis.
Negronis.
I got introduced to them, and they were as tasty as they were lethal.
Good stuff. Well, for my watch, that's been roughly 30 seconds. So I think we'll kick off. So welcome back, everybody. Thank you for joining day 7 of our tech recruitment training program. Today, we are going deep into the world of cloud computing. The title says an introduction, but I think we're going to go beyond an introduction into cloud computing today. Phil, who, if you've joined some of the sessions, you would have heard, is leading today's session. Darren's going to be on the Q&As and the chats. And we've got a special guest today, who is Yuta. So Yuta, maybe just give a quick introduction to yourself. Yeah, that'd be awesome.
Of course. So I've been in HackerJob for about a year now, and predominantly I've been working on DevOps market. So it includes sort of like sourcing DevOps candidates and also sort of managing them through the process, helping them out with sort of interviews and other things. So that's been my role so far.
Amazing. And Yuta's going to be joining us today and tomorrow and giving her perspective on the DevOps market as she works so closely with our DevOps community. So really, really excited for that slightly later on. Some quick housekeeping as always. The Slack group is now live. For those that aren't aware, we ran a poll last week, I think Tuesday or Wednesday, just because of the volume of Q&As we were getting. And I think it was pretty unanimous. People thought there might be some value in taking these conversations offline or online, but on Slack. So I think there's still quite a few invites outstanding. So please either accept it, or if you don't want to join, that's fine. Just decline the invite. It just means that we can invite other people. I think so far we've got over 100 people in the group. And I know, Phil, you're hoping to jump in at some point this week and get some Q&As going, which would be really, really exciting. Secondly, when you're using the chat feature, please chat. You need to select a setting in Zoom. Please select all panelists and attendees. It just means that everybody can see the chat. If you're using Q&A, that's fine. But if you're using chat, it just means that everyone can see it. And as always, you're going to be invited to a new Zoom webinar each day. So just check out your emails for that. Please, 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 if this has been valuable and you're enjoying it, get online and share it with people. We've got the hashtag TRT and Tech Recruitment Training. It's all on YouTube as well. So if you've missed any of the days, or if there's somebody in your team that you think would find it valuable, please, please share with them. As always, we are points meaning prizes, making this as fun as possible. So there'll be a new quiz link going in today. Right now, I think it's quite a hard quiz today, so I'm intrigued to see if anyone gets 10 out of 10 for today. And the Wine Club offer is still there, so anyone that attends 6 of the 9 sessions will get invited to the next Wine Club. And we are in contact with the Guinness World Record book to see if we can break the world record for the largest ever virtual wine tasting. So watch this space. In terms of the plan for the rest of this week, obviously today we're doing cloud computing. Tomorrow we've got DevOps tooling, and then on Thursday we're doing an introduction to data science. You can vote for your next course at that link below. And just so you guys are aware, TRT will not be stopping on Thursday. So what we'll be moving to is a weekly session. So every Wednesday, 12 till 1, we'll continue these sessions, and we'll be deconstructing different technical topics. So I think from the voting so far, I think we're going to be starting next Wednesday with artificial intelligence, which I'm sure Darren will touch on Thursday, but will be really, really exciting. So over to you, Phil. Do you want to talk us through today's agenda?
Yeah, absolutely. So first of all, what is cloud computing? Obviously, brief intro into kind of what it is before we dive in a little bit more depth. We'll go through the history of it. We'll go through the main benefits, and this section is where we'll really start to see why it has such an impact on the DevOps world, but also the impact it's had on just businesses in general, as well as kind of microservices and other concepts that we touched on Friday. We'll have a look at cloud architecture. Then we'll look at some service models. So how is cloud being used to kind of serve the wider public. The main cloud platforms out there touch on the big three basically, and then we'll look at the various kind of deployment models that you can have.
Awesome, thanks, man. So jumping in, Phil, what is cloud computing?
Great, yeah, if we jump on. So little pick here, took a leaf out of Dale's book. But I think all of us who've been recruiters for a while will probably have some sort of experience of this. Obviously, you see a lot of job titles out there like cloud evangelist and things like that. I think it's easy for companies to get kind of blindsided by you know, a need for cloud, and they have to have AWS and they have to have Azure and all of this without sometimes fully understanding how they need their hire to kind of use the cloud.
So there's the meme, and how maybe a little bit more of a practical what is cloud.
Yeah, absolutely. So we can see here all of the various different kind of end use points that are connected to the clouds. You've got tablets, you've got phones, laptops, servers, and desktops. And within the cloud, you've got three broad areas. We'll come on to these a little bit later when we're discussing infrastructure as a service, platform as a service, software as a service. But you've got your cloud infrastructure, which is essentially your network, your storage and your computing power. You've then got your platform associated things like object storage, identity, so being able to identify a user, queuing different sort of processes and things like that. And then you've got your kind of most complex level, which is hosting actual applications on the cloud, which obviously increases communication, collaboration. It can have big impact on the finances of your business, because you know there are reduced costs typically associated with moving your systems onto the cloud. So yeah, I think it gives you a good insight into kind of all of the various uses of cloud computing.
Amazing, thank you so much.
Cool. So cloud computing, as we've touched on, I think we've actually had this exact definition before, but it's worth reiterating. So cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. So basically, the term is generally used to describe data centers available to many users over the internet. So your AWS, your GCP, your Azure, huge data centers where they'll kind of store your data on their cloud servers, and it'll allow you to be a lot more flexible in the computing power that you can contribute to something, as well as how much data you can store at one time. So I know, Mark, you used the car analogy the other day, but always good to mix up the analogies. So cloud computing is like plugging into a central power grid instead of generating your own power. So again, it's using a system that's already there and that you can kind of turn the tap on and off, rather than obviously going all that length of getting your own generator and actually creating your own power. Cool.
Amazing. And yeah, I think what we'll have to produce at the end of this, Phil, is a book of anecdotes, because we certainly love our examples. Daz, any questions so far on just that high level intro to cloud computing? I know we're going to go a lot deeper, but anything from the audience yet?
No, nothing yet. There's a lot of questions on the Slack group. I know Daisy's gone back to people, so keep an eye on that. Oh, there's suddenly one just dropped in. When talking about cloud, does it effectively mean that there are centers filled with rows and rows of servers owned by Google, Amazon, and Microsoft? So I think we're talking about like server farms there.
Yep. Mark, I'll let you take this one. I think I'm going to be talking through all of this presentation, so you can jump in on this.
Yeah, and I think if you look at the last sentence in that first bullet point there, the term is generally used to describe data centers available to many users over the internet. You're absolutely spot on. Darren used the word server farm, which is another way of describing it. But effectively, the big three have effectively warehouses stuffed with servers that are then accessible over the internet. So you're absolutely spot on with your interpretation of what the cloud is. So moving on, Phil, why don't you give us a little bit of history into cloud computing?
Cool. Yeah, absolutely. So goes back as far as the 1960s, which, to be honest, I was a little bit surprised about as well, to a concept called time sharing. And when I read this, I was baffled that this was ever kind of not the case. I think when we're kind of understanding it, it just makes sense. But time sharing means that people can access the same operating system concurrently. So we discussed concurrency on Friday, so that means basically at the same time, while being unaware that others are also accessing the operating system. So it appears that they're the only user on the system, which is pretty baffling. I think we take that completely for granted, that, you know, we can be on a website and someone else can be on the website interacting with it at the exact same time. But at the time, time sharing was massively revolutionary. We then kind of jump into the next big step, which is ARPANET. And apologies, I haven't managed to remember this one. So this is the Advanced Research Project Agency Network. So it's basically the first wide area packet switching network with distributed control. So basically what it means, it was the first internet program. It was the first program to send messages over the internet. And obviously we think of the internet as coming about in kind of 1991 when the World Wide Web was launched. But as far back as 1969, there was this ARPANET system which could obviously send messages via the internet, which is the very earliest kind of form of cloud computing. Interesting, the first message they tried to send the word login, but only the letters L and O made it. So while it was the first system to send any message over the internet, it was obviously a long way from being finished. We then jump further forward to 1970, which is virtualization software, which is essentially virtualizing, so creating a virtualized version of something that already exists. So that's when you start to get into the late 70s, early 80s, where you've got very rudimentary video games and things like that. I think there was a very early backgammon game. There's a very early kind of table tennis game and things like that were created using virtualization software. So we're starting to see the evolution of computing. Obviously, huge jump forward to 1991 when the World Wide Web was released. That allowed the masses as such to access all of this online data. And then in 1997, we started to put the theory behind cloud computing. So a guy called Ramnath Chalapa at MIT, sure most of you are aware MIT tends to be pretty much at the forefront for a lot of advances in technology. He was the first one to actually call cloud computing what it was, and kind of label it as we kind of look at it now. Then we obviously move forward to the big jump, which is Amazon launching EC2, so the first kind of mass online storage platform. And then as we see, we move through 2013, 14, we are going to come on a little bit further on the next slide, but we start to see how that industry is growing so rapidly. So in 2013, 778 billion was the kind of estimate global spending. By 2014, they'd already added, another 25 billion to that. And I think if we looked at it now, then it would be absolutely through the roof.
Yeah, absolutely. For an amazing timeline. I know you've got another example that you want to talk through, maybe more from a slightly more technical perspective as well.
Yeah, I think these are the broad categories of the evolution. So obviously we started with LAN and WAN, moved on to cloud connected data management, and then utility-based cloud solutions. So LAN is a local area network. So things like schools, your own home, laboratories, university campuses could create a LAN. You're able to send messages between computers on that local area network, but not kind of beyond it. You then come on to a WAN, which is a wide area network, which is a telecoms network, basically, that spans a larger geographical area. But again, you can use that system, you can kind of piggyback on it to send messages between computers. And I mean, to this day, we still see in certain kind of, particularly with like big telecoms providers, there is still actually a need for LAN and WAN experience. I think some of our clients in that area have definitely kind of expressed that need. You then come on to cloud connected data management, which is basically the practice of storing a company's data off-site. So basically what we've already touched on, those huge server farms. So that was the first real advance, was the ability not to have all of our data on site, but to free up all of that space and give us that additional computing power. We then jump forward to the utility-based cloud solutions, which is kind of the first evolution of what we see today, which is kind of like single page applications, SaaS products, PaaS products, all of the kind of weird and wonderful things you can do with the cloud in 2020.
Amazing. And I guess one more slight history lesson for the people watching is Salesforce. Why is Salesforce so significant in the kind of timeline of cloud computing, Phil?
Yeah, absolutely. So Salesforce were essentially the first company to deliver their software over the cloud. So their kind of MO when they came out was that software should be delivered 24/7 to people over the cloud. So in the late 90s, their competitors like Oracle and SAP were still selling software to business that had to be installed and updated on premise. So you'd have to go get a disk or whatever that was and update your whole server system. Whereas Salesforce, they started off with one product, very, very basic compared to what you're looking at these days. You did have to do the initial install using hardware, but then you could go to salesforce.com and you could update your system using the internet. It would send you the data from their browser. So it's very, very basic compared to what we see today, which is kind of automatic download, automatically updating things, automatic deployment, all of this sort of stuff. Like, it was a lot clunkier, but they did essentially send you your updates via the cloud as far back as 1999. So definitely a revolution.
Amazing. And I guess, Phil, just to give people an example of that, I guess that's similar to, say, Microsoft Office, which would have been something similar at the time, right? So Microsoft Office 97, let's say, you would have had to install via a CD-ROM into the laptop to install it. And then when Microsoft Office 99 came out, you would have to purchase a new CD and install that again via the hard drive in your machine. Whereas Salesforce, their equivalent of a second version or third version, you were able to download and upgrade over the internet effectively.
Yeah. And they were innovating a lot quicker than I realized as well. They were hosting huge, big sort of tech events and conventions and all of this sort of stuff to release the new product. So over the last 21 years, they were just adding more complexity to it each time. So they were way, way ahead of the curve, yeah.
Yeah, I think that conference is still going. I think Dreamcast, I think it's, it gets like tens of thousands of people. Amazing. Before we jump into the benefits of this and why this is all so significant, Daz, any questions on the history and the timelines we've been through?
No, nothing in the chat or the Q&A. It seems like Phil's doing a great job of answering everyone's questions before they even get to it.
Fantastic. So, Phil, I know there's obviously a ton of benefits that we're going to talk through here, and we've tried to group them as sensibly as possible. But on this first page here, what are some of the core benefits of the move to cloud computing? Yeah,
absolutely. So I think, and these are things that I'm sure you touched on lightly yesterday. We touched on throughout last week when we were talking about, particularly when we were talking about the things on Friday to do with modern software engineering. But yeah, so the agility is huge. Obviously, it allows you the flexibility over your resources, which we've talked about numerous times. You don't need all of that computing capacity, all of that storage capacity at once by having your cloud computing associated with your business with having cloud servers. You can kind of scale that up and down as you need it. Huge cost reductions. So basically, it's a lot cheaper when you are using an agile model and you can scale up and down rather than buying that capacity that you need throughout the year. So I think you touched on a good analogy for that, which was the car analogy last time, which is that it's the difference between buying a car, I think it was, and kind of using like Uber or something like that. So you have that added flexibility of when you're using the resources, so that can lead to cost reductions. You've got device and location independence, so your staff can work from any location in the world, so work from home, flexi working, all of these concepts that have come into the world of work in the last sort of 10, 15 years, again, massively facilitated by cloud computing. And then easier maintenance. So maintenance is easier because they don't need to be installed on each user's computer. They can be accessed from different places. So if someone's got an issue with either their machine or with the program itself, you can kind of diagnose that and fix it remotely. Again, I think, going back to Windows versions and things like that, I'm not sure if anyone had the same issues as me, but they would periodically break, whether that was downloading too much music from Kazaa at the time or what it was. But your operating system would quite often slow down. You have to then get a new disk and reinstall it. Whereas these days, your dev team can kind of diagnose those issues and fix them from afar.
Amazing. I think you've touched on some of the real core benefits of cloud computing. I guess just that one to highlight the real fundamental breakthrough for a lot of businesses was no longer the need to own those physical servers you touched on, right? And I know we were discussing this on Friday, but the idea of a server room, I'm sure a lot of people's offices have. I know we've got one obviously in our office. It's just kind of redundant now. People don't need physical services on site. They can access all of it via the cloud, which gives them that flexibility to scale up and down. I think was one of the huge advances for cloud computing.
Absolutely.
So in terms of some other benefits, Phil, that I don't think we've touched on in any of the previous sessions yet. I think we're going a little bit deeper here. Talk us through sort of multi-tenancy and performance and the productivity element.
Yeah, absolutely. So one good thing about multi-tenancy is you can centralize your infrastructure in locations with lower costs. So again, I think we see it with companies moving their offices outside of London. So whereas in the past you might need, you might be tied to a specific location because that's kind of where your big server room was and things like that. It gives you much more flexibility on where you set your business up, because again, you can connect everything from the cloud. And again, when you come to remote working, that's that's the only reason remote working actually works. We've then obviously got performance. So if you're working with AWS or you're working with Azure or you're working with GCP, obviously they have their own IT experts that are running AWS, running Azure or GCP. So you have that additional input to your business. They can obviously assess kind of the transaction of data. They can assess your usage, and they can offer you some really good advice that they see from the entire world of running a cloud platform. And obviously you can apply that to your own business, which can increase your cost saving, increase your the speed that you're using the service, and then obviously productivity as well is another byproduct. So when you've got multiple users that can work on the same data simultaneously, then obviously you can produce results a little bit quicker, which again is why it massively impacts on the whole agile team model, cross-functional teams working on different features all at once. If it wasn't for cloud computing, then that again wouldn't be possible.
And I think that's a really interesting point you touched on there, Phil, about the partnership that you can get from these big cloud providers. And obviously we're going to go into them in more depth shortly, but at HackerJob, we use AWS, and having the access to their team, is really powerful for a business like ours. But I imagine, businesses that are going through a huge digital transformation, being able to leverage, the network of experts at AWS, whether that be their solution architects or their wider network, I imagine is a real actual competitive advantage to a lot of businesses when they're going through big transitions to the cloud.
Yeah, absolutely. I think especially if you're talking about businesses that are already at scale, where minor optimizations can actually save you a lot of money, or obviously create major efficiencies that are going to then go out and when you implement on your system are going to make you a lot more money. So yeah, I think even tiny tweaks and advice from someone who is an expert at your server provider, if you're already working at scale, could be huge improvements for your business.
Awesome, man. And just to emphasize just how important cloud computing is, there are more benefits. So talk us through the last three, Phil, before we jump onto some other topics.
Yeah, so I think these three are a nice segue into non-functional requirements, which is obviously my favorite topic. I think this is the fourth time I've been on talking about them. So I'm not going to go into detail on them again. They're on the screen there. You can kind of read through them. Should be pretty familiar with them now. But again, we can see that cloud computing gives you better availability, so better allocation of system resources, better scalability and elasticity, and better, there's a few schools of thought on this. In some instances, they can give you better security. All three of these are obviously non-functional requirements. However, there is still a bit of a debate out there about kind of the loss of control over sensitive data, the lack of security for stored kernels. I mean, at the end of the day, these guys are the pros at it. I think if Amazon Web Services can't keep your data secure, then probably your private cloud won't be too much more secure. But yeah, there is a debate going on at the moment about whether cloud computing is a secure way of storing data and sending data.
And I know we're going to come on to different types of cloud platforms in a bit, Phil, but I think that might be part of the logic behind private clouds as well, which we're seeing some businesses utilize.
Yeah, absolutely. I think it's the main logic behind it. But then again, there are, as always, there's a counter argument, and I've seen some arguments from people that work at, say, Amazon Web Services, Azure, and things like that, and they say, well, the resources we put into security absolutely dwarf the resources that most companies can put into security. So actually, the chances are our systems are more secure. Having said that, they are trying to sell AWS, Azure, and GCP, so they would say that.
There's a cynic in you, Phil. There's a cynic. And so moving on from benefits, this is a very quick overview, but just talk us through the high level architecture that is utilized with cloud platforms.
Yeah, absolutely. So put it basically, it typically consists of a front end platform, a back end platform, a cloud-based delivery, and a network. So in this instance, so you've got your cloud infrastructure there, your network, you've got your cloud service, which is a queue. So that's your cloud-based delivery. You've got the cloud platform web front end, so that's where your users interacting, and then you've got your cloud storage or your database, which is essentially the back end of it.
Awesome, man. Thank you so much. So I think we're now going to jump onto a couple of the different service models. Daz, just going to hand it quickly over to you, though you haven't interrupted yet. So I'm assuming that, Phil is doing an excellent job explaining these topics, and there's no Q&As from the audience at the moment.
No, there's a lot of Q&As in the audience. So I was just being very polite. I tried jumping in a couple of times and didn't want to interrupt. Some really good questions. I think that due to time, we might want to skim through these questions, but answer them in a good way. So the question on hiring-wise, how would a DevOps profile having cloud experience differ from a cloud engineer? Do you want me to take that one based on the session yesterday, Phil? Just quickly.
Yeah, absolutely, if you've got a good answer.
Cool. So as we discussed yesterday, there's a lot of synonyms around DevOps profiles. So a cloud engineer is just someone that focuses on cloud systems. So you will see titles like AWS engineer, Azure engineer, cloud engineer, but just someone's a DevOps engineer heavy in cloud doesn't mean that's a different profile. It's just that they've got different titles. So I would focus more on the responsibilities rather than the title. For yourself, Phil, does it matter where public cloud services are based, and how far away can they be from the client users without affecting speed and performance?
Good question. To be honest, I'm not 100% on that. I know that there's a huge AWS data center in Ireland, and I think a lot of UK companies tend to be associated with that one. I don't know if that's just ease of use when they're kind of dividing up who should go to what data center and making sure that the load isn't too much on any, or whether there is actually a correlation between kind of the geographical distance. Mark, I'm not sure if you...
Yeah, so I've got 2 points on this. So firstly, GDPR does have an impact. So I believe in the GDPR legislation, EU businesses should try and store data in the EU. So as Phil said, I think Dublin's the biggest data center in Europe. So for AWS, so I think a lot of businesses will be hosting data there. GDPR becomes a lot more challenging, not impossible, but when you're hosting or storing people's data outside of the EU. In terms of speed and distance, I had never thought about it until last week, and we were discussing this, Phil, when we were discussing Golang, but our new platform, sourcing platform is written in Go, and which, as you all know, if you attended our session last week, is used in really quick scalable systems. And our system now loads quicker, now we use Go, than the time we send a request to Dublin and back from London. But you're talking about milliseconds, which wouldn't really have an impact on performance. So I think generally speaking, people will try and store data around the world so it's accessible closely geographically, but you're talking about milliseconds from a performance perspective.
And then one final question. I know we're going to move on to AWS, GCP, and Azure a little bit later. There's a question on, within the smaller players, who do we think will catch up in the next few years?
So I think probably the one we see the most, but feel free to jump in here, guys. You're obviously speaking to a lot of candidates and clients, is Cloud Foundry, as a kind of specialist alternative provider. Now, I couldn't give you the details on the difference between all of them. I don't know if Phil or Daz, you know why Cloud Foundry is so different. But I think that's probably the one that we see as an alternative, but tiny in comparison to the big three. Phil, I don't know what your take would be.
Yeah, Cloud Foundry. You see Cloudera on quite a lot of CVs as well. Whether, and to be honest, I haven't actually researched that, whether that is one that's growing or it's just one that has been used quite commonly up to now. I'm not entirely sure.
Cool. Good one for the Q&A in Slack later. So get in there and we'll
get it in there.
We'll answer some questions on Cloud Foundry in Slack later on. So Phil, just jumping on to service models. What do we mean when we're talking about service models? I like service, please. What do we mean when we're talking about service models, and what are the three main service models?
Yeah, absolutely. So essentially it's how, broadly I suppose, it's how companies are using the cloud to serve their consumers, and how the cloud providers are serving the companies themselves. So it's how is the cloud being used? So if you're going down an infrastructure as a service route, then basically all you're asking the cloud to do is provide basic computing infrastructure, servers, storage, network and resources. So it's basically just using the virtual data center capacity. So if you guys, when you're watching back later, want to go back to the start, there's a nice diagram which kind of breaks up the three levels of infrastructure, platform, and then obviously the application level. But it's basically using the least of all of the various features that you could get from cloud computing. You're just relying on the advantages in maximizing your computing power and the advantages of having all of that data stored offsite. Cool. So some examples would be DigitalOcean, Linode, AWS, obviously, being the bigger ones, Azure, GCP. We then move on to platform as a service. So this is kind of the middle ground. So you're using a few more of the benefits you could get from a cloud provider without going fully SaaS. So a third party provider will deliver hardware and software tools, usually those needed for application development to other users over the internet. So things like Elastic Beanstalk, things like Google App Engine. So what these do is they help developers to actually create applications. So they give you the infrastructure and some shortcuts to create your own application. So they're giving you the platform and you can build on top of it. And then finally, you've got SaaS, which is software as a service. So it's a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. So that's kind of what we do, what a lot of the companies out there that you'll be very familiar with do. Dropbox, Salesforce, I think some of the earliest proponents of a SaaS model, and probably two the most successful to come out of a direct SaaS model. But I mean, there's a hell of a lot of companies out there operating that model.
Yeah, absolutely. And from a recruitment perspective, Phil, I know we're pushed for time, but what are we most likely to see on sort of a DevOps candidate's profile? Are we looking more at the IaaS and PaaS? What's, I guess, from a skill set, how does it link to the recruitment world?
Yeah, to be honest, I think you see a big mixture. I think typically when you're looking at infrastructure as a service, normally you'll see that more within enterprise clients. Software as a service typically is more at the SME end of the market, but that's not to say that they're golden rules. And absolutely, it just depends on the company that the person's come from and the background that they've come from. If they come from a company that is using cloud in an infrastructure capacity, they'll have IaaS experience. If they're using it in a platform capacity, platform, and if they're fully using it software as a service, then they'll have that background. But I think we don't see too much correlation in terms of different types of engineer coming from those backgrounds. But what I would say is what you do see on job specs is the need for experience within one of these areas. So if you've got a company that is a SaaS company or a PaaS company, then typically they're going to want to see people from that sort of background, just because they're going to have the kind of core principles and the best practice associated with that type of service.
Amazing. Thanks, man. And I know you've got a super quick image here just to kind of talk through that, or I guess display everything you've just kind of ran through there. Yeah,
absolutely. So I think this is a great image, kind of in terms of showing you what each type is using. So we've got on-premise there, which is kind of old school. You're using entirely your own servers. Everything is completely in your control. Infrastructure as a service, so you're allowing your cloud provider to manage the servers, the storage, the networking, and visualization, but you're handling the rest. When it's platform as a service, you're only managing the application and the data itself. And then when it's SaaS, the entirety of those facets are kind of handed over to the cloud provider.
Amazing, thanks, man. And as always, guys, those watching, you'll be able to get the slides afterwards, and I think that's a brilliant image that kind of displays the difference between the different service models. Do you want to give us a quick 30 seconds on the honourable mentions? I love the first one.
Yes, so backend as a service, or mobile backend as a service, it basically automates backend side development, provides APIs and manages the cloud infrastructure. And it's very useful in mobile as it allows the APIs it provides to plug in to your SDK or your software development kit, which is associated with a lot of mobile development. The main use for it, to be honest, is to plug in to sites like Facebook or other social networking sites where you maybe want to access their data. So it's useful in kind of notification services, file storage and sharing, location services, messaging and chat functions. So you'll see providers like Firebase, Azure, AWS Amplify. Essentially, a lot of what it is when you're giving permissions on your mobile. So if you're logging into an app using Facebook rather than filling in the full registration process, or you're giving access to your location to a different app using, say Google Maps or whatever it is, a lot of that will be a backend as a service system that's connecting the application with a different application out there and pulling the relevant data. Cool. And then function as a service, or FaaS, is basically a form of platform as a service. There's a minor distinction between them in that when you're using platform as a service, you're renting your servers the whole time. So, you're constantly paying for that server rental, regardless whether you're using the capacity or not. With FaaS or function as a service, you kind of turn that on and off, and it's almost the difference between having a contract mobile and a pay-as-you-go phone. So for a smaller company that maybe doesn't need to run the services all the time, and they're happy to switch things off and on, might take a little bit longer for some of your procedures to run, then you might want to go down a function as a service route, because it's going to save you a little bit of money when it comes to your cloud computing costs. Any questions on those two?
None for me. Is anything from the audience?
None on those particular questions. We've had an interesting question on what would happen to a business's data if one of these service warehouses was destroyed, i.e. a fire. So I think it's a very interesting question, because how we kind of set this out.
Yeah, so I think it kind of touches, Phil, on what we were discussing on Friday, right, around distributed systems and hosting your services on multiple different computational entities was the term we used on Friday, which basically means different computers and nodes, etc. So the way that the backups work, I believe you'd be fine, because your data is going to be hosted across a number of different server farms, etc. But I don't know what you would add, Phil.
To be honest, you had the answer on that one. I wasn't actually sure. My heart skipped a beat for a second. I thought, geez,
there was, which I guess is a slightly similar question. There was a moment, I don't know when it was, maybe 18 months ago, where AWS went down for a period of time, and it just meant like half the internet went down basically for like an afternoon. Because so many of your major applications run on AWS. So it's highly, highly, highly unlikely. It happens very, very rarely. But I do remember we were impacted by it 12 or 18 months ago. And just, there was a big outage on AWS, which meant a lot of your favorite applications like Slack, etc., went offline, which was interesting.
I've got an interesting example. When I was in New Orleans in February, I was chatting to someone that was doing a tour, and he mentioned that during the hurricane there, so Katrina, they had all the death records stored on one server, So when Katrina hit, it took out the server building, and they had to go through all the death records and then record them all again because they only had it on one server. So it wiped out all of the physical and digital records for deaths in Katrina for the last 100 years. So they then had to spend weeks and weeks building it back out.
Wow.
So
wow.
have it hosted on multiple servers is the best idea.
Absolutely, quite remarkable. So I'm just conscious of time, Phil. I know we've got Yuta joining us again tomorrow. So if we don't get to some of the questions for Yuta today, we can absolutely leverage her experience and knowledge tomorrow. But do you want to just give a quick overview of the three main cloud platforms, and then we're going to jump into the types of cloud before we'll get Yuta involved?
Yeah, I mean, to be honest, these are pretty basic introductions. Again, it's, we could do a whole webinar on the big three and what the differences are, because you're really getting quite technical when you're looking at the differences between them. But on a very, very basic level, Amazon Web Services is a subsidiary of Amazon, provides on-demand cloud computing platforms and APIs to individuals, companies, and governments on a metered pay-as-you-go basis. Azure, again, from another one of the big players, so created by Microsoft. It's basically for building, testing, deploying, and managing applications and services through Microsoft managed data centers. And then GCP was Google getting involved in the act as well. So it's a suite of cloud computing services that runs on the same infra as Google does, the same infrastructure as they use internally for its end user products, such as Google Search, Gmail, and YouTube. So it's basically just the three big players in tech getting involved in public cloud.
And AWS was very much the pioneers, Phil, as you mentioned earlier, in 2006. And we probably see them as the leaders, followed by Azure and then Google Cloud, would you say?
Yeah, absolutely, yeah. iCloud, way behind.
Cool. Nice. So just for the presence of time, this is a really interesting point and something that potentially isn't discussed that often, or is chucked around, and maybe there isn't a real good understanding. But there are different ways of utilizing cloud technology. You've got the main three on this slide, Phil. So do you just want to give us an overview of what those three different ways are?
Yeah. So private cloud is, let's go public cloud first. So public cloud is basically everything we've been talking about so far. So Amazon Web Services, Azure, GCP, the big public cloud providers. Private cloud is essentially your own version of that. So you can use a lot of the benefits that we discussed earlier, that accessibility, that availability, increased kind of reliability, all of these different facets that cloud computing gives you. So it allows you to pool shared computing resources allocated in a public cloud environment, providing a certain level of isolation between the different organizations. So you're essentially sectioning off an area of the cloud for your own private use. And then hybrid cloud is an infrastructure that includes links between one cloud managed by the user, so a private cloud, and at least one cloud managed by a third party. So you're blending the two concepts. Amazing.
And actually, I'm not going to ask that question because I think that's one of the questions we're going to ask you to. So I think, Phil, I think that's an overview of cloud computing and a very deep dive into cloud computing. We've got 15 minutes, so we've got bags of time, which is awesome. So I think it'd be amazing to get Yuta involved now. So as Yuta mentioned at the start, she kind of manages our DevOps community at HackerJob and is therefore constantly speaking with candidates that are using cloud technology. So Daz, do you want to go through the questions we've got here, and we can also include any Q&A from the audience for the next 15 minutes as well?
Sounds good. Hey Yuta, so why is there still private cloud?
Yeah, so as kind of like going back to what Phil mentioned previously, so security is one big point, although it's like, again, debatable what is more secure now, whether it's public or private. A lot of people still think that private cloud is more secure, like something that you have on your premises. And the other thing, like just generally always talking about cloud, like people always talk about money because it's quite expensive. And especially if like you're an enterprise company who have, a lot of data centers, in a long run, like using the public cloud, right, you can save quite a lot of money. But in the short term, just moving from private to public can be extremely expensive. So a lot of companies sort of use both solutions and do keep a part of like sort of private cloud.
Perfect. Does private cloud mean that companies using old tech?
So not necessarily. So again, like with the security, a lot of companies, choose to use partially like both. And a lot of most of the modern technologies like Docker, Kubernetes, Terraform, they're going to work on both of these sort of private and public cloud. Although, so like said that, like a lot of companies we see after their digital transformation, they start using public cloud at some sort of capacity. And we see a lot of startups as well. They just basically start from using only public cloud.
Perfect. And what's the most popular cloud solution?
So from the public ones, it's AWS, but like generally, as mentioned before, so like the hybrid cloud solution would be the most popular one because you get sort of best of both worlds. So you get some of like more sensitive data that can be run on your private cloud, and sort of like the rest of it can be run on your public cloud.
Cool. And the hard question here, I feel, is there a difference between public cloud providers?
So sort of like from maybe like I can answer it from more like a sourcing perspective. So I think in terms of cloud providers like the big three, so they do have their own sort of accreditations and their own like programs. So you can see AWS Architect or Azure Architect, sort of those accreditations. So people tend to sort of get quite, I think, attached to like one cloud, so like provider using one thing. It's like creature of habit kind of thing. So a lot of them would prefer to like work with a particular cloud they worked in the past. And I think what touches like AWS and GCP, I think because they do, like people using them like usually would use like all the Linux-based technologies, while Microsoft, obviously Azure is more, it works very well with other Microsoft technologies. So you would see like a DevOps engineer who is sort of more like an Azure engineer, they would use other Microsoft technologies like PowerShell, Azure DevOps, and sort of like other things that are predominantly related to Azure. So thinking like from a client perspective, if you're hiring someone for AWS role, it would be quite, it would take just longer to train someone from like Azure to everything else on AWS, like all the different technologies.
Perfect. And what is EC2, S3, Lambda?
So these are all different AWS technologies. So if you see that on CV, it basically, you could say that a person is using AWS. So EC2 have to do with sort of adding extra computing power. S3 have to do with storage, and Lambda is a platform for serverless computing. Perfect.
Cool. And this one's more to the wider group. Give me a second. It's a fairly lengthy question. It's a good one. Would smaller companies that didn't need an enterprise level of storage capacity still need hardware storage, given the cost of buying these has reduced substantially in recent years, e.g. external hard drives, or do the benefits of public cloud outweigh?
Wow, such an interesting question.
Do you want to jump in first, Mark?
Sorry, say that again, Phil?
So do you want to jump in first?
Yeah, I mean, I can speak from our experience at HackerJob, right? So I think the benefits of AWS will still far outweigh the benefits of having a physical storage device, whether that be an external hard drive or whatever. You're absolutely right to point out that memory has got significantly cheaper. I remember maybe 10 or 15 years ago when I'd have my external hard drive of all my music that obviously I got through iTunes and not LimeWire or those other sites. And, it cost quite a significant amount of money to get, a 500 gig external hard drive. But now you can probably get terabytes of data for a much cheaper cost. But with all of the major cloud platforms, you only pay for what you use. And actually, all of them have got very aggressive sort of startup plans where they will give you like your first $100,000 of AWS usage for free and stuff like that, because they want to get you hooked on the model. So I suspect that every tech startup or startup that's going to be building solutions delivered over the web will be using some cloud platform now, because the cost and the flexibility it gives you is significant when you look at the benefits. I don't know if there's anything you'd add, Phil.
Yeah, I think all I would say is, obviously we went through, I think, nine or 10 different benefits, with the additional storage basically being one or impacting on two of those. So if you think about the increased efficiencies and how quickly you can get your product up off the ground with all of those other benefits there, so the increased capacity to kind of collaborate, the increased capacity to work remotely, the increased capacity for all of these different things that add speeds to your development process. I think when you factor those in, I would say more often than not, then yes, the benefits of paying for GCP, Azure, AWS are going to outweigh the cost of it.
Amazing.
Okay, thank you.
Any other questions from the audience, Daz?
I think that's it for now. We've got a couple of questions that I think we can get to at the end if we don't get through the crowdsourcing questions.
Okay, amazing. So crowdsource recruitment challenges, as always. Yuta, I think you've touched on this. So might come to you, Phil. Obviously, feel free to jump in as well. But do you need to know C#, which is obviously a programming language written by Microsoft, to know or to use Microsoft Azure?
No, so not necessarily. So I would say when we talk about DevOps, we talk not about coding usually, but about scripting. And the Microsoft technology for like scripting language is called PowerShell. In terms of, so like C#, like DevOps engineers still might, depending like how much they're involved into like having maybe background in software engineering. So if they do have that background and if they do work in a DevOps capacity and they find some bugs, so maybe they fix it themselves instead of sending it back to developers. So obviously it's useful, but it's not prerequisite.
Nice. And I think something, Yuta, and correct me if I'm wrong here, but something I think important to point out with Azure is obviously it is used, built by Microsoft and most commonly used on Windows devices, but it is compatible with Linux machines as well, right? You can, as part of Microsoft move into the open source world with .NET Core, I believe you can use Azure across Linux devices as well. Am I right in saying that?
I believe so, yeah. I think, yeah, because obviously the newest Microsoft technologies are open source, so it should be, we should be able to do that. But from the CVs and from what I've seen in the market, it's very rare.
Yeah, yeah. I agree. You can use .NET Core on you can use .NET Core on AWS, but you see it a lot rarer on profiles or within backgrounds, because candidates tend to come from a Microsoft house where they've used Azure. So I think this is something we'll probably see in the market in the next 6 to 12 months, but it's not prevalent in the market at the moment.
Yeah, I think it comes down to what we've said numerous times about onboarding new tech. I think when we discussed Rust, for example, like it comes up super high in dev surveys and surveys of developers, but actually for businesses to onboard that technology, rewrite the software in it and start using it, it takes a lot longer. Previously companies that were using Azure would typically have been aligned to C#. So that movement of companies then onboarding Linux or a Linux house onboarding Azure instead of AWS or GCP or whatever they're using takes a long time to kind of filter through.
Yeah, makes complete sense, guys. Nice one. And then our final question, which I think we've kind of already touched on already, Daz. But if a candidate has AWS, Amazon Web Services, on their CV, does this mean they are a cloud engineer or a cloud engineers?
Am I taking this one?
Go for it.
No, would be the quickest answer to that.
Yeah.
So in modern software engineering, you see a lot of candidates that have come from a back end and they've utilized cloud. So just because they've used a cloud provider, don't assume that means that they are a cloud engineer. When you are looking at cloud engineers, like you went through, you're much more looking at stuff like EC2 and S3, Lambda, all that kind of stuff is going to point you more in the direction of what an actual cloud engineer is. Cloud engineer essentially is an expert in one cloud provider.
Yeah, absolutely. It's a little similar to what I was saying on microservices as well. Like, you know, microservices, it's the big buzzword. It's the cool thing in tech at the moment when we're looking at it architecturally. And I think developers realize that cloud is the same. It's very sought after. So that's absolutely not to say question absolutely everything, but get an understanding of how they're using the cloud or how they're building services. You know, are you just working in a cloud environment? Because most developers will be somewhat associated to a cloud. Most companies at the moment are using some sort of private or public clouds. I think it's rarer that you don't have some sort of association with one of the big cloud providers. But what have you done personally in terms of working on kind of cloud computing, if that is your business need, of course?
And just as a final question, because I'm mindful that we're coming towards the end, could someone give a one sentence description of difference between coding and scripting?
Mark, you're more succinct than me. You've given me a hospital pass there, Phil Cow. So, look, I think fundamentally it depends in the context you're using. So is it possible to give a one sentence description? So typically, when we're talking about coding, we are talking about writing front end or back end applications. So we are writing the actual code that will run the application. So that's stuff like JavaScript for front end, that's Java or Python or C# in the back end. Typically, when we are using scripting, we are talking about working at the commands line level. So think of like the classic matrix, or if you Google like command lines and terminals, typically we're talking about scripting at that level. So I think in a Linux environment, Bash scripting is probably the most popular and most common. And what Bash scripting is doing is a set of instructions at a lower level to run certain applications or install certain things on your machine. So when you install Zoom on your laptop, that will be using scripting at a command line level to install, whereas coding typically is more about writing the actual applications. Phil, Daz, Yuta, do you want to build on top of that?
No. Sorry, Phil, you go.
Scripting is typically automating lots of smaller or internal tasks, whereas coding, you tend to be actually building an application or building a program.
Yeah, exactly.
And just to confuse people, we will jump off now, but just to confuse people, certain languages can be used to write code and script. So you might often hear things being called a scripting language like Python or JavaScript. So they can be used in multiple different ways. But we've got another session tomorrow. So if that's not clear, we can absolutely dive into that in more depth tomorrow. And I'm really, really excited for tomorrow's session because we're going into what are some of the coolest technologies around at the moment. So we'll be going into stuff like Kubernetes, Terraform, etc. in a lot of depth. So tune in tomorrow, 12 till 1 for that. In the meantime, get today's quiz, which should go into the chat now. And, you know, once again, a massive thank you for everybody that's joined, another incredible turnout. And a big thank you to Yuta for your contribution today. And Yuta will be back tomorrow as well. So thank you, Phil and Daz. Thank you, Yuta. And thanks for tuning in, everyone.
Cheers, everyone.
Thanks, guys.
Bye.